In flight, manipulation of the airplane's orientation about all three axes is performed via the primary flight controls, which only include the elevator, ailerons and spoilerons, and rudder. The elevator pitches the airplane's nose up and down about the lateral axis. The TBM's ailerons roll the TBM about the longitudinal axes. Meanwhile, integrated spoilerons augment roll control by spoiling lift on the descending wing and at the same time counteracting adverse yaw created by the lifting aileron. Yaw coordination about the vertical axes is maintained with the rudder. Adjusting the airplane's orientation with the wrong primary flight control leads to uncoordinated flight. The primary flight control for pitch is the elevator. The primary flight controls for TBM roll control are the ailerons and interconnected spoilerons. The most neglected primary flight control is the rudder, which either maintains or returns the aircraft to coordinated flight. Trim is not a primary flight control. Coordinated straight and level flight is the base from which all airborne maneuvers begin. One must first have the ability to maintain constant heading and altitude. Moreover, one must demonstrate the ability to address subtle displacements in the aircraft's orientation in all three axes with the appropriate primary flight controls in order to promptly restore the desired flight path. Weight always pulls the aircraft towards the center of the Earth. Counteracting weight is lift, which acts perpendicular to the relative wind, perpendicular to the flight path. Total lifting force is greater than weight, for it must also compensate for the negative lifting force created by the horizontal stabilizer. The thrust axes of most single airplanes are not exactly aligned with the fuselage, which helps compensate for left-turning tendencies. Therefore, for simplicity, thrust pulls the aircraft forward in line and parallel to the longitudinal axis of the aircraft. Drag also acts parallel to the flight path, or relative wind, by a rearward direction. Weight acts towards the center of the Earth, but during climb, a percentage of the weight has an aft component which opposes thrust. Lift remains perpendicular to the flight path, or relative wind. During climb, an angle of attack is created between the thrust line and the flight path, which provides a vertical component, increasing total lift. During a stabilized climb performance is limited to the amount of excess thrust available at a given speed. At the top of descent point, the TBM pitches over to begin the descent. Since weight acts towards the center of the Earth, a forward component is created that complements the thrust vector. Airspeed will be allowed to accelerate to a desired value, for example 250 knots. Pitch, or a combination of pitch and power, can be used to bring the forces into balance. Since the descent phase of flight is normally flown with the autopilot on, the appropriate pitch mode is vertical speed, with adjustments in power used to manipulate indicated airspeed. If one were hand flying, pitch can be adjusted to hold indicated airspeed, while adjustments to power allow control of the descent rate. The fundamental principles of flight are learned, tuned, and demonstrated throughout preliminary flight training. How much time has passed since you reviewed these principles and considered their effects on the aircraft you routinely fly? Weak skill sets and/or overdependence on auto-flight control systems can reduce a pilot's sensitivity towards true coordinated flight. A sound academic foundation built on these basic principles is a key ingredient to maintain and enhance aircraft control.